Welcome to CAD and Sorcery. As the title suggests, today's focus is sheet metal design. Before we begin, don't forget to hit the like button and subscribe to my channel for more SolidWorks content. By doing so, you help more people discover this channel and enhance their SolidWorks skills. In the concept of sheet metal design, we work with parts that are created from a flat sheet of material. This flat material is bent to give form to a new manufactured part. So a sheet metal part is defined by thin walls, bends at its corners, and the ability to be flattened. These commands are mainly used for presenting metallic sheet metal designs. However, it's essential to note that these commands can also be applied to any part that exhibits the characteristics mentioned, like the base of a coffee packaging. Now let's explore various approaches to design a sheet metal part. Let's start by sketching the profile of our sheet metal part. To access sheet metal commands in SolidWorks, right-click on the Command Manager. In the drop-down, go to the Tabs menu, and there you'll find the sheet metal option. You can simply toggle it on or off. This makes the sheet metal commands available for use. Once the profile sketch is complete, we'll use the Base Flange command. This opens the Property Manager on the left side of the viewport, where we input information for our sheet metal design. The Direction 1 field works the same as in Extrude Thin command. Within the sheet metal parameters section, we can specify the sheet metal thickness, bend radius, and choose the direction for the profile extrusion. We also have the option to make it symmetric. Pay close attention to the bend allowance field, as it influences how SolidWorks calculates the flat pattern. In this tutorial, we'll use the K-factor approach. Lastly, there's the Auto Relief field, which determines the default relief type for the sheet metal part. Click OK to see the results. In the design tree, you'll notice three different features. The sheet metal folder, which contains the initial information, such as the default thickness, radius and relief type, and just below it, you'll find the Base Flange feature. If you expand the sheet metal features, like this one, you'll see what we call bends, which are essential for generating the flat pattern located at the bottom of the design tree. Next up is the Edge Flange command. This tool allows you to extend one or more edges in the direction of your choice. You can set extension limits using end conditions like up to vertex and adjust the flange position. Usually, we stick with the default sheet metal parameters, but you can override them if needed. Other options include trim side bends to remove extra material in neighboring bends and an angle field for non-perpendicular edge flanges. Up until now, we've been working with commands from the sheet metal family. However, it's important to note that we can also leverage commands we're familiar with from basic part modeling, such as mirror, pattern, or hole wizard, just as we're doing here. If you ever need to make changes to your sheet metal's default properties, you can do so by expanding the sheet metal folder and edit specific sheet metal features, or by modifying the entire sheet metal folder. To keep this tutorial concise, we don't dive into the specifics here. If you have any questions, please don't hesitate to ask in the comments below. Let's review our progress. When we use the flatten command, it reveals the flat pattern we've created. The flat pattern includes bend lines indicating where the bends are, a bounding box that surrounds the flat pattern, and the flattened bends which unfold to form the flat pattern. These bends originate from the sheet metal commands we've already utilized. Now let's explore the design library. Inside the SolidWorks default design library, there's a folder called Forming Tools. you can simply drag and drop these library files onto any sheet metal surface to create form features like louvers, lances, flanges and ribs. The Forming Tool Property Manager works similarly to the Hole Wizard command. It includes a Positions tab for defining the tool's location with sketch entities, and a Type tab for controlling the orientation, configuration, and other aspects of the forming tool. Forming tools are listed as features in the design tree and can be edited like any other feature. This means you can also use them in commands like pattern or mirror. Looking at the flat pattern, you'll notice that the louvers we've created are visible. To hide them, edit the louver feature and navigate to the flat pattern visibility section. There, uncheck the Show Punch option to remove the forming tool from the flat pattern. In the sheet metal commands, you'll find a corner drop-down with various options for handling corners in your model. Specifically, the Close Corner option is used to add material between sheet metal faces. It allows you to overlap, underlap, or butt connect the corners to achieve the desired result. The Hem command is used to add hem to your sheet metal part along a chosen edge. You can adjust the type and size of the hem, and if needed, override the default parameters. For this demonstration, we'll completely close it. In sheet metal design, commands like Cut Extrude can be used. They offer additional helpful options, including linked thickness, which automatically matches the depth of an extruded boss to the base feature's thickness. With our sheet metal part in its formed state, let's further modify the flat pattern. The Corner Trim command allows us to cut or add material to flattened sheet metal parts on edges or faces. You can select specific corners or use Collect All Corners. Additionally, you can choose the relief type from the drop-down menu and adjust its size. The Add Filleted Corners feature automatically applies fillets to sharp corners, making them smoother. Now let's add material to this part and move on to the next one. For our next part, we'll begin with a rectangle base. Unlike before, this time we won't create any bends, but we can still set the sheet metal parameters. I'll maintain the same parameters as the previous part. Now I'll create a sketch on this sheet metal parts face, which we'll use for the Meter Flange command. This command allows us to add a series of flanges to one or more edges, creating a box-like structure. As with other sheet metal commands, we can specify the material side and override default parameters. Additionally, we have the option to adjust the gap distance between the two formed edges using the Gap Distance field. Let's add another hole using the Hole Wizard command. For the next step, I'll quickly add a pre-made sketch from my design library for the Vent command. This command is versatile and not limited to sheet metal parts. It's a speedy way to create vents. First, you select the outer boundary, typically the outermost 2D geometry. Then, using entities like lines, circles, or arcs, you create ribs and spars, for which we can define their thickness in the corresponding fields below. Finally, we specify the fill-in boundary, usually the innermost part of the sketch. Click OK and in seconds your vent is ready. An important point I didn't mention earlier is the ability to edit the flange profile. By clicking the Edit Flange Profile button, a 2D sketch will appear. You can use 2D tools like dimensions and relations to define the geometry. Once you have finished, you can return to the Command Property Manager or directly complete the command. Next, we'll apply Break Corner to the new edge flange. You can choose between chamfer or fillet, depending on the break type you prefer. In the field below, you can specify the size of the chamfer or fillet. To wrap it up, let's utilize corner trim to add the finishing touch and complete the spot. I have already designed the base flange for this part, allowing us to move forward with the commands. Occasionally, we need to work with the sheet metal part in its flattened state. To achieve this, we use the unfold command. It allows us to flatten one, multiple, or all the bends in a sheet metal part that are currently in their formed state. Simply select the fixed face and choose the bends you want to unfold. For this demonstration, I'll select all the bends. Now we can work with the sheet metal in its flattened state. When we are finished working with the flattened sheet metal, we can easily revert to its formed state by using the fold command. It's the opposite of unfold, and it's quite straightforward. The software automatically selects the fixed face based on our previous selection, and by collecting all bends, we can bring the sheet metal part back to its formed state. What's really convenient about these two commands is that they create a designated space in the design tree for working with the sheet metal in its flattened state. However, please note that using the flatten command won't provide the same functionality. These commands only become active when the flatten command is in use. Now let's explore how the jog command works. The jog command adds material to a sheet metal part by creating two bends from a sketched line. First, select a fixed face. Like other sheet metal commands, you can override the default radius. In the field below, you can adjust the jog angle. What I find particularly useful in this command is the jog offset section. Here we can not only adjust the bend's position and the end condition, but also enable the fixed projected length option. This ensures that the face of the jog maintains a consistent length. Another command that uses a sketched line for bending is a sketched bend command. Just like before, we begin by selecting the fixed face. Then we can adjust the bend's position and change its angle. I won't be using this command. Instead, I'll create another jog. Now let's create a drawing to document the information. To do this, go to File and select Make Drawing from Part. In the View palette on the right, you'll notice that the flat pattern is already available. Simply drag and drop it onto the drawing. You can control the visibility of these bend notes by checking or unchecking the checkbox. To modify the bend notes, simply click on the text field and utilize the buttons below. These buttons allow you to print the direction of the bends, the bend angles, the bend radius, the bend order, and the bend allowance. You can even insert additional information as needed. To maintain a tidy drawing, we can employ a bend table. It lists all bends using numbers or letters in the rows, while the relevant information is organized in columns. You can even add extra columns to the table as needed. Now that we've completed the parts, let's assemble the full model. Navigate to File and then select Make Assembly from Part. I'll fast forward through the insertion of all the parts. We'll proceed by adding some mates. First, I'll add a concentric mate. Next, I'll use a width mate. The most noteworthy mate here to mention is the limit angle mate. This limits the rotation between the two components and simulates the door opening. Finally, I'll include a component from my design library, a lock for cabinets and drawers. And that wraps up the sheet metal design tutorial. I hope you found this video helpful. If you liked this video, remember to give it a thumbs up and subscribe to my channel for more SolidWorks content. See you next video.